Okay, so that is the some recap on a review on the previous lecture. So we again, like I said, that we have a linear regression and linear classification, and again in some textbook they call linear classification as a logistic regression because logistic it's the word logistic is come from the when you are cascading with sigmoid function as a linear as a with your linear functions there, so that's why they call it um, logistic regression, or you just call it as a linear classification. Just don't confuse between uh, linear function for regression and linear function for classification. Linear function for regression, you just apply a linear function. For linear function for linear function for classification, you the process is you need to cascade with another function at the back. It can be either logistic regression sign function. I'm sorry, it can be logistic sigmoid function, sign function, or softmax function. Doesn't matter. This function will make your linear equation output become a classifier. So that's why you need another function to cascade with your linear function in that block that I have drawn before. Okay, so and doesn't matter that regardless is it linear regression or linear classification. Of course you want to find the optimal weight. Okay, from this from right from this time let's use the weight. I don't want you to confuse between the w and theta. Then I will not use theta anymore. I will use w. But you to make you to understand, then actually it's related to actually it's a theta at the previous lecture. So now right now let's decide that we will use wake on this my lecture material. This can be wake or the bias. So bias is actually a theta zero, and wake or W is replacing your theta one up until theta d. That's all. So I call it wake. When I call it wake, it's also include the bias. It's also include the bias in the equation. So B is also the wake, W is also wake. And then of course then okay, let's continue. So again, that is actually the cost function, and you can see that in this material we don't use J anymore, and then we use E here. Okay, because E here, why they always use E? Because cost function is also another name for cost function is loss function, and loss function is also is related to the error. So error between the predicted output, the output that provide or produced by your function there, and the actual output. So the error between that two, uh, and then this again square. This square is actually for the purpose of to remove the negative value there to make sure that everything is positive number. So that's all. And then in of course in later you see that I'm also use 1 over 2n. Okay, this one is not, I forget to write the 2 there. So the purpose of that 1 over 2, because later when we do the derivative you can cancel between these two and another 2. So that's the purpose of give you that 2, because if you don't put 2 in this point, then you in the derivation you cannot cancel between each other, these 2 and these 2. So that's all. And of course normally in classifier you always use this type of uh, cost function. Okay, this one is related to the maximum likelihood that we have discussed before, but of course we will only focus on this one. Doesn't matter whether it's a regression or classification. Okay, So the history and the motivation of ANN. Okay, ANN start with what we call as a Mark One perceptron. Okay, this is the uh, first effort in try to introduce the ANN into this world. Okay, initially it started with what we call as a perceptron algorithm. Okay, this is 1957, the first implementation of a spectrum algorithm, and the machine was connected to a camera that used 20 times 20 cadmium sulfide photo cell to produce 400 pixel image. So it means that at that time, of course, the camera is not so good as today, and also the computer is not so fast as today. So at that time, you only can have obtain 20 times 20 pixel image, and what have been done here, they want to produce an automatic system using a perceptron algorithm that from this image it can recognize the letter of the alphabet. Means that your alphabet letter is must is come from this 20 times 20 image. Okay, so that at that time they try to develop that automated system given a 20 times 20 image that represent your alphabet A B C until Z. Uh, they try to develop an AI way where or the machine learning or ANN here. In this case, is ANN is a basic ANN where it's actually it can recognize this alphabet based on that alphabet image with the size of 20 times 20 pixels. So what is perceptron algorithm is actually still a fundamental of um, neural network. Okay, that is how they do. It's a online, and they call it as the ad hoc learning rules, where actually it's an online and offline learning. Start with the wake, initialize with 0. Okay, again wake is your theta. Just remember that. So that is that is the algorithm or pseudocode on how to do the perceptron algorithm. For each step, okay, for each example at a step, you will calculate the f here. Of course, this is your f hit, your y hit. Okay, this actually is your y hit is equal to 1 if your, okay, again this one is actually your linear equation. Okay, it should be a summation. If you talk about this is the feature, this should be a summation, because okay, sorry, actually this should be bold. Okay, again, if we bold this word, it should be a vector or a matrix. Means that this matrix contain a lot of x element. This one is contain a lot of w element. Okay, so this is how the algorithms work. Means that this is actually is a summation. Just remember that this one, if the w whole dot x each, okay, I think it should be a transpose here, something like that. So it should be your wi multiply your xi plus your b. Okay, again, I need to remind you again. This one should be theta 0 and this one is theta 1. Okay, I need to remind you again and again until you can understand the concepts there, because the formula is similar. It's not so much different. So this is the how the learning process in perceptron algorithm, where if you find out, if you want to predict uh, y here, then y is equal 1 if this linear function is more than 0. Okay, else or means at negative sides, then it becomes 0. So what is meaning by this one? Again, this is a classification, it's not iteration. Why? You can see that this one is actually can be represented with the diagram that I showed before. Means that this is your x, the whole x here, and then of course you have go into this block, the summation block with the w. So that's why this block represent this equation. Okay, this equation, and then you get v. Once you get the v, you go into another function f, a non-linear function. At this time you are using a sine function. So the sine function is should look like this. Okay, means that uh, positive v will make your y hit positive 1, negative v make your y hit negative 1. Okay, so let me draw this again. So this is the v, so this is the your y, so this one is plus 1, this is minus 1. So any if this value is actually will produce v, like you see in this block. So if the v more than 0, your predicted y become 1. If your v less than 0, your predicted y is, oops, sorry, this is not sine function, sorry, this is not sine function, I'm sorry. Okay, it's not a sine function. They are using f, which is another function. This is called a unit step function. If you remember unit step function, how actually the unit step function. This is another non-linear function that I don't introduce before because this is the old function. But because we discussed about the history here, so that's why we find more and more non-linear function that has cascade with your linear function. So another function that I don't discuss instead of sine function, logistic function, and sigmoid function or softmax function, another one is a unit step function. So if you remember unit step function, I think you learn this in signal and system. Unit step function should be something like this. Okay, anything if this is v, anything uh, make your v more than 0, then your your functions there, if you talk about this is your y hit, if this one will become positive 1. If the v there is less than 0, your y hit here become 0. So this is actually a unit step function. So f here is implemented with this unit step function in perceptron algorithm. So that is the basic uh, or the first effort in producing the neural network. But of course, later you will see that how does this one relate with the neural network. But this is actually the first effort in extending. Later you will find out from this finding they try to related or try to relate with artificial neural network, and then they expand the idea in mimicking the behavior of human brain. So this is the oldest technique in artificial neural network. As you can see that uh, this is actually is not a linear function because you actually there's a two blocks there. One is a linear, this one is represented by this one, and the whole picture here is a unit step function. So that's why I draw another f there, which represent a unit step function. So if you express or you combine this equation, this block and this block together, then this is where we can express this whole system as this expression. So you can see that anything if you find out the this linear function value produce more than 0, your predicted y here become 1. And if you find out the if this linear function produce uh, the output which is less than 0, then you set your y head become 0, which is like your unit step function here. So that is during the when you want try to fit the data, fit this equation into your the given data, but to update the w, or in previous lecture we talk about to update the theta, then this is the rule that they have been used in perceptron algorithm. So I think this one, if you see the updating process is almost similar with the gradient descent that we learned in previous lecture. You can see, but it's almost similar, but not similar in terms of the how they derive this one from the previous lecture. But of course, uh, to update the W, you have the learning rates and the input X there, and then this is the error there, the difference between the actual output and the predicted output, and then you will update all W there because you have d-dimensionality of inputs. Of course, if you have a d-dimensionality of input, then you need to have d uh, d numbers of value. Okay, if your feature is 2, then your W, you also have the W1 and W1 and W2 plus the bias. Okay, so again that is similar to the previous lecture. If you have two variable x1 and x2, you will have theta 0, theta 1, and theta 2. So theta 0 is bias, theta 1 is W1, and theta 2 is W2. So that's that is the similar things. And then you update, and you will keep updating this one. Okay, that is the perceptron algorithm. You can see that this one should relate to the linear regression and linear model for classification. So that's why when you learn a linear regression in the previous lecture, that is actually is a basic for ANN, because if you talk about the history of ANN, the first finding, which is perceptron algorithm, is actually is a linear model for classification. Okay, linear model for classification, where actually the f here is a unit step function. Okay, and then to train this function to get a fit, um, to fit the function or the classifier with your data, then this is how they update the W. Okay, however, the perceptron algorithm eventually find a hyperplane. So again, hyperplane is the another name for the this function. Actually, hyperplane is the equation represent the border that separate between two value, class 1 and class 2, or minus 1 and class belong to plus 1 and class belong to minus 1, or class, if you talk about sigmoid function, class whether that point is belong to plus 1 or minus 1. If you talk about this one unit step, this can be uh, is it belong that point is belong to plus 1 or 0. So that is still a binary classifier, because you will classify the given input into two classes. Okay, it doesn't matter it's negative 1 plus 1, or 0 or 1, is still a binary classification approach there. Okay, so if a hyperplane exists, but the disadvantage of perceptron algorithm is that if no separation hyperplane exists, the algorithm does not have a converge and will iterate forever. Means that this operation will do iteration forever. There's no stopping criteria. Okay, at that time people don't think about the stopping criteria. They just update the W up until they find out the best fit function that can fit into your data. But let's say you find the case your data is non-linear. It's not a linear. It is not cannot separately cannot you if you find that the case where is not is a non-linear separable is not cannot be separate linearly, then this iteration will go forever. So that is this disadvantage of linear perceptron. Okay, so this is the what this is the okay. You can imagine that this is the case that I talked before. I talked previously. Okay, of course, in this case, it's a it can be linearly separate between these two. But if there any if you find out, let's say if you have a data which is cannot linearly linearly separable, then your algorithm will not stop. It will iterate forever. And of course, if you talk about if you implement the same algorithm in your computer, it will be hacked because the for loop is not stopped. So what are the example of non-linearly separable data? It's something like this. For example, let's say, okay, this is should be just remember this one is x1 and this one is x2. So let's say I have something like this. I have x1, I have x2. So how to do, okay, something like this. Okay, I let's say I just do some label like this. Okay, I have a dot. That this one is class 1. Okay, and this is class 2. This is my data. And then you have another here, class 1. So this is example of data which is might it is not linearly separable. So means that maybe I have another point here. So I have class X and class dot. So of course, if I using the linear perceptron algorithm, is very it will continuously iterate up until your computer will hang there because it's do a for forever. So that is the disadvantage of perceptron algorithm. But for these cases, it can be solved because it's linearly separable between class blue and class red. So which that is the advantage of linear perceptron algorithms. Okay, then from this, they try to extend this finding into logistic regression. This is the logistic regression where they try to introduce to you with another functions there, which is called a sigmoid function. Okay, I don't want to discuss this one anymore. So again, this is what I draw as before. Logistic regression is related to sigmoid, like I said in my previous lecture. They call it logistic because now this f here they are using a sigmoid function. So once they are using a sigmoid function, then they call it logistic regression. And again, this is a summation. So this one is related to this operation, while this one is related to this operation. So so it's a class still a linear classification, but this one work better than perceptron algorithm because the perceptron algorithm, the f here is a unit step function, where actually the disadvantage there is uh, it's not linearly. It's a can only classify the data which is linearly separable, but uh, sigmoid function is work better than that because it's okay. There is a sigmoid functions there. Okay, now your fx estimate the probability. Okay, again, this one is also have discussed in the previous lecture 6. It's not where uh, I think we have you have been exposed into the reason why sigmoid function, because sigmoid function is related to instead of giving why head here as a continuous number. And now your y head is actually represent the probability. Okay, the probability of your the probability whether this one is belong to class one, class class one or class two, uh, given the x. Okay, given the x. So so in order to do that, that's why they introduce with the logistic regression, because logistic regression will give in terms of probabilities. So whether your x is belong to class one or whether your x is belong to class two. So that's why logistic regression is a again logistic regression is a classification model, and the function f here is a discrimination function itself is not linear anymore, but the decision boundary is still linear. So this is the advantage of again this is the advantage of logistic regression that you uh, have been uh, taught before. Uh, even you manage to change your linear regression into logistic regression by cascading your linear equation or linear function with this sigma function, you manage to come out with function which is discriminate between the point belong to class 1 and the point and belong to class 2, but still the the boundary decision or the boundary is a hyperplane here, like this one, as you can see in this uh, figure here. It's still linearly separable, which is still you have this disadvantage in solving this case. Okay, that's mean a Ceptron algorithm failed to classify this one, and your logistic regression also failed to classify these cases, because you can see that in these cases you cannot create a border or equation that represent a border that can separate between uh, the point that belong to class dot and the point that belong to class cross, because you can see that there's a two area here. So in this case, this is where people extend the logistic regression into come out with the and also the combination of find all the finding by the neuroscience. They see it seem to be when combine these two together, they find out actually neural network can solve this kind of problem where the data is not linearly separable. Later we see that. Okay, okay, this is the same things that you learned before. This is MSE. This is the cost function against the to regression. You are using the maximum likelihood. Okay, okay. We will start to talk about neural network in next lecture. But as a summarization, as you can see that this is the history about the neural network. Before the models, the artificial neural network based on human biological neurons. Okay, this is the finding that they have been used, or the effort towards finding the artificial neural network. So that's why again I stress on this is that I highlight on this is that why you need to learn a linear model for regression or linear model for classification in the first part of the lecture. Uh, that is because that is the fundamental of artificial neural network. As you can see through this history, when this Mark 1 Ceptron has been discovered, you find out that they build a machine that can classify the alphabet by using a perceptor algorithm, which is this one. And you see that this is where you learn in the previous lecture, which is related to linear model for classification. Of course, we don't cover the unit step function, but we cover the sigmoid function and softmax function, which is having cascade with the linear function over here. So, but originally, the linear ceptron, before they know about the sigmoid function, they introduce with this simple as a unit step function is that if your linear function here is more than 0, then your y predicted y or y hit here equal to 1. If this linear function produce negative number, then the y hit here is equal to 0. So in order to do that, your f here should be a unit step function. And later, of course, this is the how the learnings rule at the beginnings. But of course, from time to time, this learning step is have been improved because originally there's no stopping criteria to stop this step. And then after that, they extend this version into logistic regression. So from the logistic regression, instead of using a unit step function, they are using a sigmoid function. Okay, now the output there is not uh, either 0 or 1 anymore. Is actually is a the y hit actually now will become the or represent the probability. What is the probability that given this input it should be belong to class 1? What is the probability given x, this x is belong to class 2? So in order to do that, then they replace the unit step function with sigmoid function. So the name logistic here is come from this sigmoid function. So that is the things. Okay, this one has been discussed before. And of course, again, like I said, uh, during the when you apply the sigmoid function, uh, the cost function there you can use either MSE like this one, or you can use a maximum likelihood function. But in the lecture 5, slide in lecture 5, we exposed to you with this one for linear model as a linear model for classification, because this one is work better than this in terms of finding the result, because this result is not a non-convex model, so means that it's very hard to find uh, the minimum value or the minimum point, while this one is work better and very fast to find a minimum point to optimize your wake or to optimize your theta. But later when we talk about linear artificial neural network model, I will only I will only focus on using this one, the MSE, not the maximum likelihood cost function. Okay, because I just want to scope. I will just want to limit the scope there in your syllabus, but of course, just remember that uh, to make it as a classification, this one work better than this one. Okay, but if you talk about uh, supervised learning for regression, then this one is work better. So that's it. Okay. So later, okay, next lecture we will continue with later how actually where is actually the architecture of neural network come from. Okay, of course that you need to understand a little bit about the behavior of the neuron inside the biological human brains.